Welcome listeners now to the third part of our discussion on groundwater, and after we have discussed about the movement and occurrence of groundwater, that how groundwater occurs in different kinds of aquifer and how it is moving from one part to other part due to the changes in the hydraulic gradient and other factors as well during this discharge and recharge processes. So, now we will be looking at mainly what is important to our daily life, that is the production of groundwater, that how we can use groundwater by digging wells and other ways, and also what comes in consideration along with the production is the overproduction. If the groundwater that you are producing or extracting from the deep aquifers is over extracted, and sometimes this over extraction or overproduction will also lead to the contamination of groundwater due to several other processes. So, starting with the first thing, that is the production of a groundwater. Obviously, to use or produce groundwater, we generally dig wells or use pumps or sometimes some tube wells as well. So, a water well is a cylindrical structure that drilled, dug or constructed into the ground to have an access on the groundwater for various purposes like drinking, irrigation, industrial, or sometimes, which is nowadays important, that is monitoring of the groundwater as well. So, there are different components of a well. I will not go into the very detail of the components, but again, like the structure says, if there is an aquifer, you are digging a well like this, and you are putting a pump at the beneath of the your well. So, from there, due to this pump, you can easily discharge the water out of this well that was dug by you. So, obviously, there has to be a casing so that your other sediments or other materials are not getting inside your well, and it is not contaminating the supply of your water, because actually you are looking for fresh water. That is why you have dug some well into the surface. Now, whenever you are producing water or you are discharging or you are taking out fresh water from the groundwater body or an aquifer, what is happening, that a cone of depression, will be looking into that. A cone of depression, a cone shaped depression is formed due to the lowering of the water table or the piezometric surface around the pumping well. So, if you are taking out water quite fast, then obviously there will be a depression in the water table. Earlier the water table was kind of a flat surface like this. So, if you are pumping the water table at a faster rate out of this surface, what will happen, due to the flow of the water through the well, it will develop a conical kind of a surface. So, it forms due to extraction of groundwater from an aquifer, which creates a localized area of decreased water pressure and draws towards draws the water towards the well. So, when groundwater is pumped from a well, it creates a hydraulic gradient around the well with water flowing towards the well to replenish the extracted water. The rate of water withdrawal exceeds the natural recharge rate of the aquifer. So, sometimes when you are overproducing groundwater, leading to a lowering of the water table or piezometric surface in the vicinity of the well. Over the time, the cone of depression will expand and deepens as pumping continues, influencing the flow of groundwater in the surrounding aquifer. So, it has very characteristic shape. It looks like a conical surface. The depth of the cone of depression depends on factors such as pumping rate, aquifer properties, and how fast it is getting recharged or how slow it is getting recharged, and radius, the lateral extent of how big your cone of depression is. The lateral extent of cone of depression varies again on the depending on the aquifer's hydraulic conductivity, recharge characteristic, and duration of pumping. So, apart from natural factors, always the main factor here in case of the formation of a cone of depression, that how fast you are discharging the water from an aquifer. If you are discharging the water at a very slow rate, for example, you are running a pump only twice a month or thrice a month maximum, then there is high probability that the water table will be again restored through the infiltration that is going on. But in the summer season, for example, you are pumping too much water for irrigation purpose, then obviously till the monsoon is coming or till the rainy season is there, you have a lowering of groundwater due to overproduction of the groundwater, or the lowering of the water table due to this cone of depression. But if in the rainy season as well, that much water is not getting recharged, and you have overproduced the groundwater much more than it can be recharged over a rainy season, and again in the next summer you are again discharging water, eventually what will happen, year by year this cone of depression will grow in size, resulting into the falling or depletion of the groundwater level. So, we will be looking at that in due time. So, this is a typical three-dimensional view of groundwater flow and contour. So, your flow will be obviously from higher contour towards the lower contour like this. So, this is the surface water that you can see that has been generated due to this flow of the groundwater. So, this is a stream. Now, alongside, if you have also put a pump like this, a pumped well, so with continuous discharge of water or groundwater from here, what you are creating this conical zone of depression. So, that is why it is referred to as a cone of depression, where your groundwater flow, now you can see, have a much steeper gradient in comparison to that of its earlier relatively gentler gradient. So, now you are depleting the water very fast. So, your cone of depression is forming with very steep angles. So, definitely it will lead to the reduction in your groundwater level, changes in the flow direction, even land subsidence, because also remember that when the pores that are filled up in this zone of saturation, that are filled up by water, it is also due to this water pressure, it is also supporting the land that is just above the zone of saturation. So, in the zone of aeration, where it is only filled up by air, now you have in the zone of saturation, it is filled up with water. So, that water or water pressure will also support the land that is thus present over the aquifer. But if you draw the whole water out, what will happen? There will be a reduction in the water pressure there, leading to subsidence of the land under its own weight. So, obviously land subsidence might take place. Salt water intrusion, we will be looking at an example of salt water intrusion later on. So, the management and to stop this kind of formation of cone of depression and its effects, we can manage it by optimize pumping, means pumping at regular interval, not erratic pumping or pumping water daily on daily basis. You are overproducing groundwater, so you have to keep a stop to it. Then artificially recharge by processes of, for example, rainwater harvesting is a very popular process nowadays to recharge groundwater. Then imposing other regulatory measure such as management policies and restriction and integrated planning, that how your groundwater can be saved by wise planning, means wise land use planning, so that it is not affecting the water table at a very faster rate. So, now if I again look at the overproduction in an unconfined aquifer like this, so if I am digging a well and I am drawing some water out of it, so it will form a cone of depression like this. And if I stop this well for some time, what will happen? Again the water will take its own place. It will flow towards the well, because always you are discharging the well. So, once you stop discharging the well, again the water will flow towards the well, and again this cone will be, means you can say this cone will vanish once you are not discharging any water from that well for a long period of time. So, This is how your cone of depression forms. Now if I take the example that if you have this kind of a water table, and in a locality you have, for example, you have in some countryside area or in some village area, you have two houses. Those two have your this wells or pumps that are using groundwater daily, like this. So what will happen, due to this discharge of groundwater, there will be a formation of a cone of depression like this. Okay, but with increasing population in that area, again a couple of more houses are present now, and they all have their own pumping wells to obviously dig out water from the aquifers. So now you have 3 or 4 houses who have continuously this, or who are discharging water continuously from the aquifers like this. So now earlier when there was only 2 or 3 houses in a large area, they also used to discharge water from this aquifer, but in that case this cone of depression do not intersect one another. But when there are now multiple homes in the space in that same locality, and now you have multiple wells or multiple pumping system to dig out the water from the aquifer, now the cone of depression that is forming with respect to the each and every well, now they are intersecting one another. So you have a cone of depression of the first house like this, that is intersecting the second one. The second and cone of depression is intersecting both the first and the third cone of depression from the third pumping well, for example. So now you have a continuous intersection of this cone of depression leading to fall in the water table. So now you have a continuous intersection of the cone of depression. Earlier there was a water table which has a single cone of depression. Now you have multiple cone of depression leading to what? A lowering of the water table like this. And if this goes on and again monthly and yearly, again and again it is getting discharged more and more, the water level will continue to fall down deep and deep. So that is extremely detrimental for a long term you can say sustainability. So you can't sustain for long if you are depleting the complete well of an unconfined aquifer. Then if you have completely depleted it, now you have to go much deeper to find an confined aquifer, again from which you can get the supply of your groundwater or fresh water. So that is a problem. If you are overproducing your groundwater, then there will be this multiple development of your cone of depression leading to a general fall in the water table. And if the production or the discharge of the groundwater is obviously more than that what it can be recharged during the time of precipitation or during rainy season, for example. So in that case what will happen, that subsequently the water table will fall. So in case now when you have exhausted, and that is very bad to say, but still if you have exhausted the unconfined aquifer, now to find water you have to go even deeper to a confined aquifer. So now if you have this confined aquifer, like the idea we discussed when we discussed about strictly about confined aquifer and artesian wells related to it. Now so again you have this pressure surface or a piezometric surface that is like this. So these are, this ridge or this hill is kind of your main recharge area from which your water is getting recharged into the aquifer, and this is your regional water table. So if you can dig a well directly to the confined aquifer, then you can also get an artesian well if means in case you are lucky enough. Otherwise you will dig a well that is obviously a non free flowing artesian well, where your piezometric surface is just cutting the well at an angle like this. And if it is beyond the piezometric surface, then remember that this part of the aquifer will be devoid of any kind of groundwater. So again, you are not only you have already exhausted the unconfined aquifer, you are now started to exhaust or deplete the confined aquifer as well. So again, it is extremely, means these aquifers are again and again vulnerable to this kind of depletion in case of overproduction. So now if I overproduce again these wells continuously, what will happen? The overall piezometric surface or overall piezometric or water pressure surface will reduce or will fall down, resulting in again and again depletion of the aquifer like this. So finally there will be again wells where you will not get any kind of water supply, but still there will be a few wells near the recharge area where there is a probability of still getting some artesian wells. So it is always better to use the water if some artesian well is present which is naturally discharging the water. In that case, you can simply utilize that water or trap that water that is getting naturally discharged, rather than digging a deep well into the confined aquifer directly and simply depleting the aquifer at a faster rate. So it is again a matter of, like I was saying, the matter of management or the policies that are generally introduced by the government when this kind of problems happen. Very recently there has been in India as well, there has been multiple reports of this shortage of groundwater and depletion of this kind of aquifer in different parts of India, especially in parts of Delhi, in parts of Bangalore. There are extreme problems of this groundwater depletion due to huge discharge or overproduction of the groundwater, resulting into now the aquifers are completely exhausted and they are not getting recharged at that rate in which it is getting discharged, resulting in the depletion or exhaustion of these aquifers. Then coming into the contamination. So now contamination can also happen if again you are discharging water at a quite faster rate. So now I'll simply take you to your coastal environments where obviously there is a already there is a dirt in your fresh water, because obviously coastal area there is seawater that is mainly controlling the dynamics of the hydrological cycle. So there is always a dirt in the supply of the fresh water, but still there are aquifers that are present as we go inside the land from the sea. So if again over pumping of groundwater is happening, or sometimes sea level is getting increased, in that case again your groundwater may get contaminated by the saline water. We will be looking into that. Apart from that, it can happen by some natural geological processes, by some faulting or some fracturing in the strata, also sometimes some land subsidence that is happening. So if I look at this diagram now, so if you are having a freshwater aquifer sitting just side by side along the sea like this, so this is your land, this is your coast, this is your sea level, and there will be a contact always between the fresh and the seawater, you can say. So this is referred to as the freshwater seawater interface. So now if you are looking at an aquifer which has a water table like this, to acquire fresh water, you have now digged a well like this and you are pumping water out of it. So what will happen? Obviously the cone of depression will be formed first like this, a cone of depression develops. Then what will happen that as subsequently you are or continuously you are discharging it with the help of a pump, what will happen that this freshwater seawater interface will try to migrate inward into the land, because as it is going on, more and water you are means more and more water you are simply discharging it with a pump. So the water will try to flow towards the well to support the discharge. Obviously what will happen, this freshwater and seawater interface between the freshwater aquifer and the saline water intruded zone will try to finally reach to the well. So a time might come, then a freshwater tube well might become a saline water tube well. Means whenever you are trying to get some fresh water out of that tube well, you are getting nothing but saline water. So that is the moment when you have to stop any kind of discharge from that well, because otherwise this seawater freshwater interface will finally enter the well, and it will now continuously, it will start giving you saline water. So once you stop it and you close it permanently over a long period of time, then with subsequent precipitation and freshwater infiltration, what will happen again, this interface between the seawater and the fresh groundwater will again move back to its original position, means towards the sea. So unless you have a very good recharge mechanism that is going on in this kind of an area, your depletion of freshwater aquifer in the coastal region is very fast, leading to this mechanism of seawater intrusion, that seawater is intruding within the aquifer system in the coastal area. So this kind of seawater intrusion problems are present all along the coast of the Indian peninsula, be it your east coast, be it starting from Bengal, your Orissa, then Andhra Pradesh, Tamil Nadu, or be it in the western coast, be it in Goa, be it in Gujarat, be it in your Karnataka, Kerala, all these places, there are zones, they are extremely affected by seawater intrusion. Again, there is a little variation in the east coast. The problems of seawater intrusion are little bit more in comparison to the west coast. Again, that is related with the idea of when we discussed about coastal landforms, constructive landforms and destructive landforms. So your east coast is offering you destructive landforms, your west coast is offering you with gentle slope. So the seawater intrusion will be relatively slower in nature, rather than in the east coast where it is destructive coast, you have a steep slope. So the seawater intrusion will be faster in whenever there is overproduction in the coastal aquifers. So there are ways also to prepare artificial confined aquifer, and they can be recharged, and the benefits of it that they provide enhanced water storage capacity, improved groundwater management, and but always the challenges is about the site selection, construction of maintenance cost are involved. So an artificial confined aquifer, if you want to prepare, you can take a nearby freshwater stream which is relatively pure in nature. So in that case, the first method is to stream flow is directed to an artificial recharge basin that you have prepared or you have constructed, where your water percolates downward to the underlying aquifer. That way you can, because you are storing that water, so it has ample time to infiltrate into the soil. So that's how you can recharge an aquifer. Second method, a recharge well is used to pump treated water into a deep confined aquifer. You already know the position of the deep confined aquifer. So here you are doing it in a reverse manner. You are pumping, you are not using a pump to extract the water, you are simply pumping fresh water deep within that confined aquifer. So this way you can have or you can manage and you can recharge these zones of where your aquifers have already exhausted or under extreme depletion. Like this kind of processes should be applied in, you can say, region surrounding Bangalore, so that the aquifer system beneath the city of Bangalore can be recharged over a period of, for example, a few decades, that can be recharged over this time, so that again we will get a continuous supply of groundwater. But again, the responsibility will be to use that groundwater wisely, not use it like or simply waste it whenever we want. So another way, your this thing I just want to discuss a small thing that we generally see in means you can say means in urban areas, that there are tanks, large water tanks that are installed at several locations in a city. So what is the purpose of establishing this kind of water tanks? So if you have a regional water table like this, and if you are drawing water to a large water tower like this, so now what you are doing, you are enhancing the water pressure of the whole region by installing a series of water towers across the town. Now you have increased the water pressure level. So whenever you are supplying water, and it is generally done by municipal people, municipal corporation of an area. So whenever you have a tower like this, so you have increased the water pressure of that region. So now whenever you are supplying water from that tower, or your some water supply is being it means water supply system is present in that city, due to this high pressure of the towers, of the high water pressure, the water gets supplied very easily. That's why you need to install water storages at high level, so that the water pressure gets maintained. So again, that concept is actually drawn from the idea of the prismatic level. So naturally means this natural phenomena is getting kind of applied to our daily water supply systems. So before I end my discussion on groundwater, next we will be moving to only the last part. I will not say directly related to means you can say surface geomorphology. What we will be looking at in the next lecture is the subsurface formation of karst topography, that is mainly governed by the groundwater, not by surface water. So we will be dealing with karst topography, the landform formed by groundwater, in our next lecture. So before I conclude, I would like to again state the statement that groundwater is a non-renewable resource. You have to use it wisely. So be careful with that. Thank you.